These are some of the most massive bursts of radio energy in the universe, releasing the equivalent of 1 billion suns worth of energy. These bursts' extreme intensity and radio frequency generation will eventually be noticed by the entire universe. The James Webb Space Telescope, which provides us with profound insights into the deepest mysteries of the universe, has discovered something alarming, breaking news from space. Betelgeuse, a star that is well known for its bright presence in the night sky, has shown signs that it might go supernova in 2023. As we contemplate the ramifications of such a heavenly occasion, a surprising disclosure from the past surfaces: the mysterious cosmic explosion SN 1987A. Could the secrets it holds reveal important information about the fate of Betelgeuse? What implications might this have for our planet? Go along with us as we dive into this inestimable riddle. Since its launch, the James Webb Space Telescope has been at the forefront of astronomical discovery. It has enabled us to explore the universe's farthest reaches and unearth long-forgotten secrets thanks to its cutting-edge instruments and unparalleled capabilities. Betelgeuse and its potential supernova event in 2023 are one of its most recent and alarming findings. What has the JWST revealed? We should research. Understanding another significant astronomical event, the explosion of SN 1987A, is essential before delving into the mysteries surrounding Betelgeuse. This supernova serves as a crucial point of reference and provides valuable insights into the dramatic beginnings and endings of massive star life cycles. It helps us understand how stars like Betelgeuse act. A recent image of SN 1987A taken by the telescope's near-infrared camera revealed its intricate structure. Notwithstanding, this cosmic explosion was first seen in 1987 when cosmologists saw quite possibly of the most splendid heavenly blast in the night sky. A brilliant flash of light that could be seen from Earth was produced by this explosion's release of a significant amount of energy. It stays one of the nearest supernovae saw in hundreds of years. Astronomers have been paying close attention to its expanding debris ever since it was found to learn more about how stars change. SN 1987A, coming about because of a monster star's dangerous passing, is found 168,000 light-years away in the huge Magellanic Cloud, a satellite cosmic system of the Smooth Way. From radio waves to gamma rays, this supernova gives off a wide range of electromagnetic radiation. It has been studied using renowned observatories like the Chandra X-ray Observatory and NASA's Hubble and Spitzer space telescopes. But the James Webb Space Telescope has given us a new look at this famous supernova. The most precise images of the supernova, which show its equatorial and outer rings, crescent-shaped inner ejecta, and distinctive keyhole structure, were obtained through the telescope's near-infrared observations. The stellar explosion released dense gas and dust clusters in the image's center. The keyhole's dark area is because this dust is so dense that the JWST's near-infrared light cannot penetrate it. A bright equatorial ring formed by debris ejected tens of thousands of years prior to the supernova surrounds the inner keyhole. Additionally, the supernova shock wave interacting with the structure of this ring resulted in the formation of glowing hotspots within this ring. New crescent-shaped structures, thought to be part of the supernova's outer gas layers, were also discovered by the JWST's sensitivity. The dense core of the neutron star in SN 1987A makes it difficult to identify it, despite the fact that neutron stars typically form after a supernova. One of the universe's largest and brightest stars, a blue supergiant, most likely died in this explosion. The universe is full of unpredictability, as SN 1987A demonstrated. Betelgeuse may soon be the next cosmic mystery to awe us. Is it true or not that we are nearly seeing another heavenly occasion that could adversary or even surpass the stunningness of SN 1987A? NASA astronomers have discovered a revelation that has stirred the scientific community, and they are eagerly awaiting developments. Betelgeuse, renowned for its constant brightness, has begun to decrease, not gradually but abruptly and clearly. The star's brightness has decreased significantly in a short time, as shown by JWST observations. What could have sped up the dimming so quickly? This is no ordinary star, Betelgeuse. With a diameter roughly 900 times that of our Sun, it is a massive object. Its outer surface would extend beyond Jupiter's orbit if it were situated at the center of our solar system. Enormous stars like Betelgeuse have short life expectancies and end their lives dangerously, frequently coming about in supernovae. Not only are these explosive events captivating, but they are also crucial to the universe. They distribute elements like carbon, nitrogen, and oxygen, which are necessary for life to exist in its current form. Basically, the death of stars like Betelgeuse adds to the beginning of life somewhere else. Is it possible for a huge star like Betelgeuse to simply vanish without a dramatic conclusion? The response is both fascinating and complex. This phenomenon has been the subject of several proposed explanations. The observed dimming could be caused by dust clouds obscuring the star's light, according to a popular theory. Betelgeuse and other older stars frequently shed their outer layers, releasing a lot of dust and gas into space. This material can make thick mists that occasionally block the star's light, causing it to seem dimmer according to our point of view. According to recent observations, Betelgeuse has been emitting more material, leading to these dust clouds. Red supergiants like Betelgeuse, in particular, go through this process on a regular basis as part of their life cycle. Another hypothesis includes heavenly throbs. Huge stars, for example, Betelgeuse, every now and again go through patterns of extension and compression. The star may dim during contraction phases as a result of these pulsations, which can result in brightness variations. Betelgeuse-type stars frequently exhibit this behavior. The outer layers of the star are pulled inward by the immense gravity of the star, causing it to contract, while the core's heat pushes them outward, causing the star to expand. Over brief intervals, this rhythmic pulsation can cause noticeable brightness shifts. The most alarming theory, on the other hand, that this dimming might be a sign of a coming supernova, has received a lot of attention. Might we at some point be nearly seeing perhaps of the most breathtaking occasion in our vast area? A star's mass determines its life cycle, and Betelgeuse, which has a mass 20 times that of our Sun, is bound to explode in a supernova. The abrupt darkening could demonstrate that the star is draining its fuel and is going to fall under its own gravity. In the past, stars that suddenly dimmed occasionally burst into spectacular supernovae. Not only are these explosions beautiful to look at, but they also disperse essential elements into space, which is important for the evolution of the universe. Utilizing its suite of advanced instruments, including the near-infrared camera, the mid-infrared instrument, and the near-infrared spectrograph, the JWST began observing Betelgeuse well before any potential supernova event. High-resolution images. For instance, the mid-infrared instrument MIRI is able to observe and detect the heat produced by the dust surrounding Betelgeuse in the mid-infrared spectrum. The star's health and impending demise are both revealed by the dust that forms as a result of the outer layers being shed. Astronomers are able to reconstruct the star's recent history, current state, and potential future by analyzing this dust and the light it emits. Astronomers have long been captivated by the mysterious nature of Betelgeuse. Despite its size and brightness, the mystery of its surroundings truly piques the imagination. Betelgeuse is a variable star, which means that over time, its brightness changes. Betelgeuse's variations stand out among the many stars that exhibit this behavior. These changes have been noticed for north of 100 years, and however they were at first remembered to be standard, late perceptions have demonstrated them to be more sporadic. This mysterious star gains even more intrigue from its unpredictability. What drives these swings? As a red supergiant, Betelgeuse is a turbulent environment for nuclear reactions. Hydrogen atoms fuse to form helium deep within its core, releasing a lot of energy. The outer layers of the star expand as a result of this energy pushing outward. As these layers grow, they cool down, prompting a lessening in brilliance. At the point when the external layers contract once more, they heat up and build the star's glow. The brightness variations we observe are the result of this cycle of expansion and contraction. Astronomers are able to gain insight into the internal dynamics of Betelgeuse by observing each pulsation. Scientists can learn more about the star's structure, composition, and future by studying these pulsations. For example, have you at any point asked why stars have various varieties? For what reason are some blue, others yellow, and some, similar to Betelgeuse, a splendid red? The shade of a star is straightforwardly connected with its temperature. Blue stars are the most smoking, with temperatures arriving at up to 30,000 degrees Celsius, while red stars are cooler, with temperatures around 3,500 degrees Celsius. Betelgeuse is regarded as a relatively cool star due to its reddish hue, but the term cool is misleading. If you tried to get close to Betelgeuse, you would die long before you got there. The Betelgeuse's age is yet another intriguing feature. Large stars like Betelgeuse, despite the fact that it may appear counterintuitive, despite their abundant nuclear fuel, have shorter lifespans than smaller stars. The fact that massive stars burn their fuel at a much faster rate is the cause of this paradox. Betelgeuse, on the other hand, will only last for a few million years, whereas our Sun, for instance, has a lifespan of approximately 10 billion years. Betelgeuse has proactively survived the majority of its life, and its ongoing stage as a red supergiant demonstrates that it's approaching the end. Now, the question is not whether but when Betelgeuse will explode. A series of intricate nuclear reactions will take place in the core of Betelgeuse as it gets closer to its end of life. These responses will create heavier and heavier components until it arrives at iron. The core will no longer be able to use fusion to generate energy at this point, resulting in a catastrophic collapse. A supernova will occur as a result of the collapse of the core, releasing an inconceivable amount of energy. Even during the day, this explosion will shine brighter than entire galaxies and be visible from Earth. A spectacular light show that could last for weeks or even months will be created as the shockwave from the supernova sweeps through the outer layers of the star. The possibility of witnessing such an event in our lifetime becomes increasingly real as astronomers observe Betelgeuse's dimming. A cosmic explosion blast of this size would be a rare occasion for mankind. When Johannes Kepler saw a star explode in the Milky Way in 1604, it was the last time the naked eye could see a supernova. Since that time, several supernovae have been observed using telescopes, but none of them have been as close or as bright as Betelgeuse's. In terms of astronomy, the star is relatively close to Earth because it is only 642.5 light-years away from us. If Betelgeuse went supernova, the night sky would see an unprecedented display. The consequence of a Betelgeuse cosmic explosion would likewise have critical logical ramifications. Astronomers would be able to study a lot of data from the explosion, which would help them comprehend the processes that take place as a star dies. Moreover, the cosmic explosion would disperse weighty components into space, adding to the development of new stars and planets. The demise of Betelgeuse would, in a sense, plant the seeds for new life in the universe. However, there are potential issues that accompany such an event. Earth could be affected by supernova radiation, especially if it was close enough. Fortunately, Betelgeuse is far enough away to not pose a significant threat to Earth's life even if it bursts into flames. We would be shielded from the most harmful radiation by the Earth's atmosphere, and there would be very little impact on our environment. We ought to be excited about the possibility of witnessing one of the most extraordinary events in the universe rather than being concerned about it. The chance to get up close and personal with a supernova is one that we may never get again. We can only speculate about what might happen next as we keep an eye on Betelgeuse and wait for any new developments. Will the star once more shine? Or will it dim and eventually explode? One thing is certain, the Betelgeuse mystery is far from over. However, time will tell. The James Webb Space Telescope will keep on assuming a significant part in disentangling this secret, giving us new bits of knowledge and potentially seeing the last snapshots of perhaps of the most renowned star in the night sky. In conclusion, the James Webb Space Telescope's discovery of the sudden dimming of Betelgeuse has sparked a flurry of speculation and excitement among astronomers. We are reminded of the universe's unpredictable and awe-inspiring nature when we compare this event to the famous supernova SN 1987A. One thing is for certain. The mysteries of the universe continue to captivate us, regardless of whether Betelgeuse is about to explode into a supernova or is just going through another phase of its life cycle. Keep an eye on the night sky as we wait to see if Betelgeuse will soon present us with one of the most spectacular shows in the universe.